Hi everyone. Today is Thursday, August 16th, and this is IPSM, Intro to Post-Secondary Math. So today we're going to try to go off a little bit what we did yesterday with slopes, and this is under the Unit 1, which is called Linear Equations. But today we're going to be doing solving multi-step equations and slope of a line. We're going to combine them. Your learning targets today, we're going to solve linear equations of properties of equality and combining like terms. We're going to solve linear equations containing fractions. I'll show you an easy way to get rid of those. We're going to recognize when an equation is an identity and when it has no solution. And we're going to identify graphs with positive, negative, zero, no slope. We did that yesterday. And we're going to calculate the slope of a line using the formula or counting rise over run. Again, we did that a little bit on yesterday. So here's come fill in the blanks here. The goal of solving a linear equation is always to, does anyone know? It is to isolate the variable. That means get the variable by itself. Example, IE means example. Get all x's on one side and all the numbers on the other side. Something like this. Get the x's on this side, numbers over here. Okay, get all the x's on one side, numbers over here. So combining like terms, okay? Combining like terms means something of equal sign. If they have equal sign, combining like terms means what? What do you think that means? Combining like terms means of equal sign. Combine terms of, well, that's kind of what it says. Combine terms of equal sign. For example, if you had a 2x plus a 3x, what would that equal? It would equal 5x. Okay, that's combining like terms. If you had 2a plus 3b plus 4a, which ones would you add? The 2a and the 4a, because they have like or equal signs. So this is 6a plus 3b. This next one, I'm not sure what it is. I'm not going to lie. Do the blank when moving from of equal sign. I'm not sure what that means. So, do the inverse. Do the inverse when moving from, okay, again, I don't even know what this is, but we're going to do the inverse. So what does inverse mean? If you have addition in a problem, you want to subtract to get rid of it. So I'm going to give you a quick little example. If you had x plus 4 equals 7, how could you isolate the x on the side? How would you get rid of plus 4? You would subtract 4. That's the inverse of adding. The inverse of adding is to subtract. These would cancel. You'd get x equals 3. Remember that? What's the inverse of multiplication? Division. So, example, if you had 2x equals 6, how would you get rid of multiplication of 2? To get x by itself, you would divide by 2. And whatever you do to one side, you do to the other, and x would equal 3. If you have a power, how do you get rid of it? A root. So if you had x square equals 9, something like that, how would you get rid of the square? You would square root both sides. So x would equal 3. But with square roots, there is something you have to remember. Whenever you take a square root of both sides like that, you have to put a plus or minus in there. I don't know if you guys can remember that, but basically 3 squared is 9, but so is negative 3 squared. So there's actually 2 answers when you have a square like that. Special cases, if you're solving an equation, sometimes you can get infinitely many solutions, other known as identity or all real numbers, or sometimes you can get no solution. So that might happen when we're doing one of these problems, and I'll show you when. So let's go to example 1a. So what you have here is your equal signs. What I like to do is I always like to put a line down like this. So you have the left side and you have a right side. So on the left side, you cannot combine like terms. But on the right side, you are going to combine like terms. That's what we said up here, combine like terms. So if they're on the same side, you're going to combine. So basically you have a k here. A k actually means that you have one of them. So you have 1k, and then so I like to underline them, and you have 3k. Before you can move things back and forth from left side to right side, each side has to be simplified. So the right side has 3 terms. That's too many on one side. So combine a couple of them. So we're going to combine the k terms. So 1k plus 3k is 4k minus 5. And then you still have the 2k minus 1 on the left side, and you still have your equals. Do you guys understand that step? We added these 2 terms. Now you can't do anything to k and 1, and you can't combine k and 5. So now is time to start doing the inverse operations. So you would like to get the variables on one side. Remember how I said right here? Try to get the x's on one side. So right now we have 2k on this side, and we have 4k on this side. So you have a choice. You can either subtract 4k over here, or you can subtract 2k over here. Some of you guys are probably saying, get rid of the smaller one. So it doesn't matter. You can get rid of either one. So let's say we subtract 2k from both sides. So the k's cancel on this side, and you get this negative 1. Carry down that subtraction sign. Now it's really, that subtraction sign becomes a negative 1. Equals 4k minus 2k is 2k. Carry down the minus 5. The next step, now we're solving for k. You're trying to get the variable k on one side and all the numbers on the other side. So what's the inverse of subtracting by 5? Adding 5. So I'm going to carry this over here. So negative 1 plus 5 is 4. The 5's cancel on the right side, and you're left with 2k. And what's the inverse of multiplying by 2? Dividing by 2. So k is 2. A good thing you can do sometimes is to mental check this. So if you get a 2, you can go 2 times 2 is 4. 4 minus 1 is 3. 2, because I'm plugging a 2 in, 2 minus 5 is negative 3. Negative 3 plus 6, if you plug the 2 in, is 3. So 3 equals 3, and that's right. So on this one, going to be here. Draw your line down here. Which side is not simplified? Hopefully you're saying the left side. You have some distributive to do. So you should distribute the 3. That should give you 6z minus 3. 6z minus 3. Do you guys remember how to distribute? The right side is 6z plus 5. Now this is one of those ones that's going to be tricky. It's either one of these special case ones. It's one of the special cases. It's either going to be infinitely many or no solution. And the reason I know that is when you get down to a simplified right side and a simplified left side, you can tell that the z term is the same. Whenever that happens, it's going to be a special case. So because when I try to get the z's on the same side, I would subtract them like this, and all the z's are gone. So I can no longer solve for a variable. So what you're seeing is the remaining numbers equal or not equal? Is negative 3 equal to 5? The answer to that is no. So therefore, it is no solution. If these numbers would have been the same, you would have said infinitely many. It means every answer in the world would work. But in this case, this side will always be 8 larger than this side. Because 5 is 8 larger than negative 3. Okay, next one. Someone think about what you would do in C. Let's look at it. The left side is definitely not simplified. But what am I going to distribute? Hopefully you're saying to distribute the negative sign. We're going to distribute the negative sign with 1 and with the negative p. We're distributing. So recopy down 2p. We're not distributing 2p. That is not what's in front of the parentheses. The negative sign is in front of the parentheses. So the opposite of 1 is negative 1. And the opposite of negative p is positive p. So whenever there's a negative like this on the outside of parentheses, everything inside becomes its opposite. So it was a positive 1, now it's a negative 1. It was a negative p, now it's a positive p. So let's recopy the right-hand side. Now the left-hand side has still got too many terms. Do you see how there's 1, 2, 3 terms? That's too many on this side. So we're going to combine 2p and 1p. How many p's do you have? You should say 3. That's 2, and that's 1 more. Carry down the subtraction of 1. So now you have p's on both sides. So your next step should be to get the p's on the same side. So this time I would like to add p. to the left side and to the right side. So they cancel on the right side, and you get 11 plus 11. Wait a minute. Oh, sorry. I'm sorry. It's just 11. It's not 11 plus 11. Never mind. Forget what I just said. On this side, 3p plus p is 4p. I'm running out of room here, so it's 4p minus 1 equals 11. So I'm going to copy that down right here. 4p minus 1 equals 11. Solving for p, we would add 1 next. Divide by 4, and p is 3. Next problem. So what should we do on the left-hand side? I'm going to put my line down here. On the left-hand side, I can distribute the 2, but I still have the subtraction of t at the end. So once I distribute the 2, I still have to subtract the t from these terms. On the right-hand side, we're going to distribute 3. Are you ready? 2 times 5, 10t. 2 times negative 3, negative 6. Carry down the subtraction of t. So on the left-hand side, if you add these together, what's 10t minus t? That should be 9t minus 6. That side is now simplified. So we distributed and we combined like terms. On the right-hand side, we're going to distribute the 3. That gives us 9t minus 6. Ooh, what do you notice about the left side and the right side? They are identical. So remember those special cases right here? Sometimes people say infinitely many solutions, but aka identity. Identity means the sides are identical. So this is one of those infinitely many solutions. That means no matter what number I plug into t, it's always going to be equal to this side because they're the same expression. But if you want to get down to there, if you subtract 9t, say these cancel, you're left with negative 6 equals negative 6. If the t's cancel and your remaining statement is true, it's infinitely many solutions. Or you can say identity because they're identical. Okay? So E, how do you solve an equation with fractions? You could just subtract 1/2 from 11/12 and use a calculator, or you could get rid of all the fractions by multiplying everything by something called the LCD, which is called the common multiple. What is a number that is a multiple of 3, 2, and 12? Hopefully you're saying 12, because 3 times 4 is 12, 2 times 6 is 12, 12 times 1 is 12. All of these have a multiple of 12. So what you would do is you would multiply 12 to each one of these fractions. So you might not remember this, but this is what you do. So what you're thinking is, what is 1/3 of 12? In other words, 3 goes into 12 4 times. So that's 4 and then carry down the x. That's your new term, 4x. And the next one, it's 12 times 1/2. 12, the common multiple, times what's in there. 12 times 1/2. 1/2 of 12 is 6. And in the last term, the 12s cancel completely, and you're left with the numerator 11. And doesn't that look easier now? Subtract 6 for x equals 5. Divide by 4, and x is 5/4. So we started with fractions, and our answer ended up being a fraction. I know I kind of did that fast, but we'll get a chance to practice a little bit more. Let me just make up another fraction problem real quick. What if you had 1/4 x, oops, let me write that again. 1/4 x plus, say, 2 equals 3/8. What would a common multiple, so first of all, this one's got a denominator of 1. What's a common denominator? 4, 1, and 8. A multiple, not a factor, a multiple. So you should be saying 8. So if we multiplied everything by 8, what's 1/4 of 8? In other words, how many times is 4 going to 8? You should say 2. So 2 times 1x is 2x. Nothing cancels in the middle one because it was a 1. So you just multiply 8 times the numerator. In the third term, the denominator 8 cancels with this multiple 8, and you're left with the numerator 3. You'd subtract 16. 2x equals negative 13, and then x is negative 13/2. That's just an extra problem. You don't have to do that. Okay, that's your notes. Now, go ahead and get out your homework.